at this raw sugar. Now this raw sugar, you need to know, it looks like that. Because it is brown. Because it is still brown. Okay, you see these things like this. It is still brown. So what that means, the molasses is still there. So what they do? They do a next step called affination. They're going to add more syrup there. And then they wash with water. Which means we add something there, then they dissolve the more, then they go in through the water. However, this process is expensive plus high energy requirement. So lots of the companies want to disregard that. Okay? They directly go to clarification. In here, what they do, they have something more, little bit complicated. They're using double carbonation. Sometimes they also add sodium or sulfite dioxide. This is they try to remove some colorants, not all of them. Okay? After clarification, they have to do a filtration. Then they move into an important step, is decoloration and deaminization. Sometimes softening, not always. How they do decoloration? Two methods. Number one is using ion exchange racing. Number two is so-said activated granule carbon. Then they try to remove ash and mineral. Okay, once this guy is finished, same thing, you needed to reach 60-80% dissolved solids. Then what you do? Crystallization and centrifugation. Then you get white refined sugar. Okay? Of course, molasses is still there. Now, what's the difference from here? From the beets? Beets basically is you combine them all. And we said a little bit briefly, because we already talked in detail. This slicing is V-shaped slicing. You cut like a V shape. Then this diffusion, we don't put lime there. We not put calcium hydroxide there. We're using 85 degrees Celsius water. Then this clarification, we do directly, we go ahead to do double carbonation, and we adding sulfide dioxide. So directly we do premature decoloration. Then this sink juice, we go to multi-stage evaporation. Become a 6 juice. Same thing here, we are using ion exchange racing and the granule activated carbon. So these steps looks like very similar, but we jump in here. Then we do crystallization and centrifuge. Then become white sugar and then molasses. this is still the same thing as byproducts. But most of the time, chromatography, they can do analysis to see how purified it is. Okay? So this is the one we talk about, the sugar refining. Okay, when we talk about here, before we talk about the polysaccharides, we have another slide right here. I don't know where they jump in here in the textbook. It is kind of we already mentioned. I think maybe they just duplicated typed it again. But anyway, we can review here. This is called amino sugar. Okay, glucose-CME, what happened? Glucose, this one, carbon number 2 has an amino taken there. Okay, then sometimes this can be acidylated. So NH and COH3 then become a chitin. And more they polymerize to become a chitin. And then we're going through partial hydrolyzing, which means we remove this acidyl group, then become more concise, and then become a chitosan. And what's the function of this chitosan? It's a good packaging machine for absorption and also have some antimicrobial activity. And also could carry some of the antioxidants or antimicrobials. There are lots of research that did in food microbiology area to see the packaging material of chitosan, to how they inhibit like E. coli, O157H7, Listeria monocytogenes on food, fruits, vegetables, and the food and the meat products. So this is slides. I don't know where they jump it, but just there to show you the chitin and the chitosan, how they formed. And at the beginning, the glucose-CME, you have acetate. Then this is a simple polymer, then acetate is gone through hydrolyzing, and then become the chitosan. Okay, so just like a review, I think it might be mistyped there. And we know the amino sugar, actually the backbone of the chitin, is more popular than major components in insects, some seafoods, crustaceans, mollusks, and some mushrooms. And we actually have another slide to talk about already. Okay, so we end up here. Then next week we talk about polysaccharides and another big one for the starch. Okay.